To explain a rational quadratic system, we could draw our rational function. So that's our basic rational function. And if we were to draw a quadratic, so this is one with just one asymptote. If I were to draw a quadratic to this, we could potentially draw a quadratic with three solutions like this. Okay, we could draw a quadratic that has three solutions like this. So in a rational quadratic system, we could have a maximum of three solutions. Okay, and the minimum then for the rational quadratic function, we could have something that looks maybe like this, but eventually, okay, with the quadratic system, this would have to at some point cross over one of the rational lines, because this shape here, this slope is going to go more vertical, but this is going vertical much quicker. So at some point we're going to have one solution. Okay, so that's the minimum number of solutions and the maximum number of solutions. And there are many cases of rational quadratic, but this is just for the basic rational function with one asymptote and a quadratic. If I have a quadratic in x and a quadratic in y, so this is a quadratic in x, a and x squared, this is a quadratic in y and a y squared. So a quadratic in x, if I draw this out, this happens to be a perfect square, so it's going to bounce at x equals 1, and it's going to kind of go through there like that, and we have our quadratic in x. And this being a quadratic in y, all we've really done is switch to x and y. So instead of facing up with a y-intercept of -4, this is facing sideways with a y-intercept of, x-intercept of -4. So we're just really switching the x and y's, and then just drawing it with when x is 0, and if you want you can make a table of values. When x is 4, y is 0, -4, y is 0. Okay, and then we can rate our zeros when y is 2 and -2, x is 0. So we can have, our coordinates like this. I should draw this a little bit further down here. And so if you were to draw your graph in, the graph looks something like this. So it's going to come through there, vertex, and through here. So although potentially there are 4 intersection points, in this example, we can see that this section does not intersect the upper parabola, the parabola facing up. So we have 2 solutions here, and I'm going to go to my graph to find these 2 solutions. So I end up with, sketch my graph in here. And so that's going to be so my solutions for this graph, and I'm using technology to do this. Okay, the intersection points here, so I'm going to looks like this intersection is at -0.379, so I'm going to round that to 0.38, and 1.90 for y. So that would be the solution for both. This fits on both the graphs. And the other intersection point for my graphing tool, I get this point here is 2.603, so I'm just going to round that to 60, and 2.569, so 2.578. I'm going to round that to 2.57. So those are my two sets of solutions for this quadratic in x and quadratic in y. And I use technology to do this at this point. We will eventually use algebra to solve this.